All right, so again, triangle congruence today. ASA, AAS, and HL, section 4.5. Does anybody want to take a guess what ASA might stand for? Angle, side, angle. AAS? Angle, angle, side. And the third one, HL. Hypotenuse leg. Okay, so there it is. First one we're talking about today is what's called the included side. Yesterday we talked about included angle. Remember talking about yesterday it was included angle? So if I gave you a triangle like this, the included angle was the angle between the two sides that you knew. Okay? An included side now is the common side of two consecutive angles of a polygon. So an included side says that something like that. That would be my included side. Why? Because it's in between two consecutive angles of the polygon. So let's look at a triangle up here. If I gave you angles like that, would that be an included side? Yeah. Would that at the top be an included side?
No.
No. Would that be an included side? No. Would this be an included side?
Yeah.
Would this be an included side?
No.
Would that be an included side?
Yes.
Would that be an included side? Would that be an included side? That one.
No.
That one. Okay, so you're trying to recognize where the included side is. Okay. So here's what this looks like here. Angle, side, angle. What do you notice about angle, side, angle? The side is in between the angles. That is key. Angle, side, angle. The side is in between the angles. So again, if I look at it down here, notice my side is in between the angles. My side is in between the angles. Therefore, I have angle, side, angle. Okay, the side is in between the angle. Angle, side, angle. Now, let's look at a couple problems here. So number one says determine whether you can use ASA to prove the triangle's congruent. So if we look at number one, what do I know here in number one? What's going to be the same as angle K?
Okay.
Does everybody agree angle K and angle N are the same?
Yeah.
Okay. So yeah, angle K is congruent to angle N. What do I know about my side lengths here? They're both 8 centimeters. Would that mean my side lengths are the same measure? Yes. So I could say KL is congruent to NP. Does everybody agree with that?
Yeah.
Great. Lastly, what else do I know here? L and P are congruent. So angle L is congruent to angle P. I have an angle, a side, and an angle. Does everybody agree?
Yes.
I have an angle, a side, and an angle. Is this an example of angle, side, angle?
Yes.
Yes. I would say these are congruent based on angle, side, angle. Nice job. Okay. You just put ASA, it's fine. Number two, triangle EFG. Now let's look at it here. Angle G, is that the same as angle Z?
Yes.
Okay, I'm good there. Yes, sir.
Do we have to write out angle K?
No, I'm just kind of showing you the out right
I
now.
was going to say, because if we can just see it as...
Yeah. Angle F, is that the same as angle Y?
Yes.
Okay.
So like when you're ASA.
Yep. Now comes the tough part here. What do you notice about ZY down here? Okay, is GE 5 centimeters?
Oh,
GE is 5 centimeters, right? But let's look at this here.
but it's not the same.
I have up here side, angle, angle. Does everybody agree with that? The side is not between the angles, right? On the bottom here, I have angle, side, angle. Are they the same thing?
No.
So can I say that those two things are congruent then? No. So this would be an example of cannot be determined.
Wait, so which ones are we all going to compare with that? ASA?
We're going to do all of them today. A little bit of all.
I don't forget all of these.
Okay. Again, they have to be the same congruence shortcut. Number three. Now, number three is kind of a tricky one here. Why? Because you have to use some prior knowledge to help this one out. Triangle KLM and triangle PNM, given that M is the midpoint of NL. So if M is the midpoint, what's it mean to be a midpoint Anderson, what's midpoint mean? What's that mean if it's in the middle, though? So if M is in the middle, what do you know about NM and ML? Would everybody agree those two sides would have to be the same?
Oh, yeah.
Yeah. Okay, if it's in the middle, those two sides have to be the same. Now let's look at these two lines. Does everybody agree those two lines are parallel? How do you know they're parallel? Because it says they're parallel, right?
Does that mean that MK and MP are the same too?
No. It does not.
What has to be the same?
What it does tell me, though, is if this is 90 degrees right here,
That's
So
what
it's
I mean.
90 degrees.
isn't this going to be 90 degrees right here?
Yep.
Okay. Now, I have two parts of information. Does everybody agree? I know an angle, I know a side. Is there anything else I know for sure based on facts? Not like, well, it looks like it's the same. Is there anything else I can say for sure it is true in this statement? Like, can I say that these two angles are congruent?
No.
No, I can't say that. Can I say that these two sides are the same? I don't know that for sure, right? I can't say that. Can I say that these two sides are the same?
Yeah.
Do I know that?
Yeah. We do because
Do I?
they're the arrows.
Could I draw a diagram like this? Have a 90-degree angles here and have those both be the same? Would those be the same shape? Those are the same shape? Right here? No, I don't know anything else. This one's actually going to be cannot be determined. Why? Because I only know two parts of information. All I know is an angle and a side. Not enough information. I need at least three things here to help me out. There is not enough information on number 3 here to give me that it's the same.
That one's
Okay, let's look at 4. Do I agree I have an angle the same?
Yes.
Okay. Do you agree I have some sides the same?
Yes.
Okay. What else do I know here in number 4? There's one other thing I do know for a fact to be true in number 4. Who can identify it? Who can identify it? There's something else. Huh? I agree. T is the midpoint. T is the midpoint of WV, right? That makes those two congruent. Good. Colton, what are you thinking? Ah, very good. Does everybody see right here in the middle? What do I have right there in the middle, Colton? Vertical angles. Vertical angles are always what? So does that make these two angles congruent?
Yeah.
Ah, now what do I have here?
You have a ASA.
That would give me angle, side, angle postulate there. Again, I have to use information of prior knowledge to help me solve some of these. For example, vertical angles. Vertical angles, there's going to be a lot in these problems. You have to be able to recognize that. Okay, midpoints. You have to know that midpoint cuts things in half, makes them equal. That's going to be big. Okay. Next thing we're going to talk about is AAS and HL. Again, what's AAS stand for?
Angle.
Angle, angle, side.
That's what
That means now, is my side in between or not in between?
not.
Okay, notice my side is not in between my angles. It is on the outside of the angles. It's not in between.
So can it be also at the bottom one?
It could have also been at the bottom. Great question. Does everybody hear what Reed said? He said, could it, instead of being here, could I have that down here? Would that still be angle, angle, side?
Yes.
It would. Yes, nice job, Reed. And then last one, talk about hypotenuse leg. This is a special one. Hypotenuse leg only works if I have a right triangle. So if I have a right triangle, this is the only time you could ever do the naughty one here and technically get a congruency statement. Why? Why does that work? Because it is a right triangle. And we do not say ASS or SSA. We call that
Ace.
hypotenuse
They
leg.
made it hypotenuse leg because it made a bad word.
No, it's just because it's only true for right triangles.
No.
So it's only true if you ever know the hypotenuse leg, which is then based off of Pythagorean theorem, basically is what's from. Does everyone remember Pythagorean theorem?
A squared plus B squared equals C squared.
Yeah. I just grained that in your brain there.
I'm never gonna.
Dang.
That's
that
gonna be like my.
hypotenuse
That's gonna be a quote at my funeral. I still remember Pythagorean theorem.
All right, so hypotenuse leg works for right triangles. Okay, so let's look at number 5 here. It says, determine whether you can use HL congruence theorem to prove that triangles are congruent. If yes, explain. If not, tell what else you need to know.
Those aren't.
So 5. What do I know in number 5 here?
I know that.
I have a right triangle, right? So right triangle tells me it could be a hypotenuse leg. Okay, right triangles are only, or hypotenuse leg is only used for right triangles. Do I know some sides are congruent? I know the hypotenuses are congruent, right? Do I know anything else about this triangle?
No.
Sure?
Yeah.
What about this right here?
Yeah, let's say.
Do they share a side?
Yeah.
They share the side here, don't they? So this is an example of hypotenuse leg. This is an example of hypotenuse leg. Why? Because they share it. They share that side. 6. Do I have an angle here in 6? Yes? Do I have a side in 6? Do I know anything else in number 6?
Yeah.
Do I know anything else in number 6?
Or is the midpoint?
Do you know R is the midpoint? How do you know that?
Because
It tells you that?
it's in the middle. But no, that's not true. I don't know.
Yeah, what if it's not the midpoint, Reed?
This one you cannot be determined here. Okay? It cannot be determined. Why? Because I don't know anything else. Let's say Reed were to be correct. Let's say we do say, what if it says, okay, now I add R as the midpoint?
How would we know that R is the midpoint?
It'd have to tell you. Okay? What if I gave you the information R is the midpoint now? What's that make my segments down here at the bottom? Okay, is this an example of HL then?
No, that would be side, angle, side.
This would be side, angle, side. Nice job. Why side, angle, side? Because I have side with included angles. How would I have to know that this is HL? I'd have to know that my hypotenuses are all the same. If I know this information, now that would be HL. So recognize the differences between these different shortcuts. Okay? Alright, like you take a couple seconds, try these 4 on your own. Take a couple seconds, try these 4 on your own. They're either going to be angle, side, angle, 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 side, or HL, or cannot be determined. Take a couple seconds, try these 4 on your own. Alright, let's look at number 7. I think a lot of us got number 7 correct. That was good. Caden, what's number 7?
HL.
Number 7 is HL. Okay, number 7 is HL. I have a right triangle. I have congruent sides, and they share the hypotenuse. That's HL, right? Good. Now, number 8. Some of us start struggling now, number 8. What do we see? We saw some congruent angles, right?
Yeah.
What do I know about the bottom down here, though?
That's
They're both going to be right angles. Why?
they share.
Because if they share a line, and the one side is 90 degrees, the other side has to be 90 degrees, right?
Yeah.
And now what do? They share this line in the middle.
So it'd be angle, side, angle.
So 8 would be angle, side, angle. Nice job. Now number 8, or not, sorry, number 9.
Can't be.
I have an angle. Great. I have a side. Great. And they share a side. So technically here I have ASS. What is the only time that ever works though? If it's a right angle. Do I have a right angle here? So what's this one going to be? CBD. Cannot be determined. Okay, nice job. Yeah, that one cannot be determined. Why? Because it's not a right angle. If it were a right angle, now could I say that would be something? Yes. And what about 10 here? I have some angles, and they share a side. That would be angle, angle, side. Nice job. Okay? Here's your assignment.